I'm not even gonna dump on wireless because I don't want to cover it really well. All right, so 3 things. Open, short, failed power source. And that kind of covers it. Now, that said, primarily because of this naughty little thing called parallel paths, it can be very, very difficult to isolate, particularly the open, or the partially open. Okay, so to talk about each of these, the most common place you're going to find opens, unless something really weird happens, is going to be at connectors. You're going to have a pin pushed, a pin broken or pushed back. Might be something happening there. This is kind of hard to see if there's a problem unless you get a bright light and look in there. Shorts, on the other hand, of course, this one's pretty scary. They had a short, put tape over it, and short it again. Might kind of think, well, okay, maybe we should do something different. But it's also a little strange. I guess there is no lid because the latching mechanism for the lid is trapped behind the wires. I'm not quite sure how that works, but so anytime the electrons do not go where we want them to go, we're going to call that an open or partial open. Okay, some reduction, some increased resistance, reduction in current flow, all the way to complete stop of current flow. A short will always be when the electrons go somewhere that we did not want them to go. Now, oftentimes we think of a short as, lots of spark, big heavy smoke, fried stuff, etc. It's not uncommon in the world of shorts, although they themselves aren't very common. It's not uncommon in coils and armatures and those types of things where you have a bunch of windings for you to have a fairly short distance short. 1 or 2 windings are circumvented. That creates a situation where the unit usually still works. However, the amount of current going through it is going to go up. So let's say I've got a relay being activated by a transistor driver, maybe it's a fuel pump relay in your car, being operated by a transistor driver in this computer in your car. And it's got 10% of the windings shorted. Current's going to go up, right? And because the current goes up, the magnetism is going to be probably about the same. So the relay is still going to work. Only the transistor is going to get hotter. Right? Do you know what the appropriate resistance is for a typical relay? No, but you might want to pull a new one off the shelf and measure it if you don't have that value. Do something to get a good value, because when you go to measure that with an ohm meter, you're going to read, 2,000 or 3,000 ohms. Think, well, maybe that's right. At that point, the only thing you can do is go back and compare against a known good component if you can't find the data. Or might you find a relay? No good relay. How about the one next to it? At the end of the day, though, if you pull the computer out and it's got something fried in it, there's a good likelihood a short was part of the problem. Power sources can be a variety of things. Again, in all likelihood, we had a short in one of these. It started getting hot because all the power being generated by all the rest of them was being driven through the short here. As it got hot, it burnt insulation, shorted more. It started burning insulation in other ones, and they started shorting. Okay, this problem continued for a while. On the battery, a number of things can cause them to go. Primarily, it's either a dead short in the battery, causes it to get really hot, and it starts to melt, or occasionally, and again, you really have to work hard to do this, but it is theoretically possible to where you could have a vent, one or more vents get plugged, and you're in a charging cycle, and it builds up pressure, and it's a pressure rupture. Most of the time when you have a battery fail, it just internally shorts, gets a little warm, and it's instead of putting out 13 volts, it puts out 9 volts. Or maybe 2 start to go and it gets even worse, right? And when you put any load across it, it drops down to 3 or 4 volts, which isn't nearly enough to excite a starter or anything else. So typically what's going to happen is with these guys, the shorter open will take out 1 or 2 windings, and then things get hotter, and then the insulation starts to fail. So part of the reason that shorts are, I think one of the things we can say about a short is they are a testament to good insulation. They're pretty rare. Now, is that because the designers do a pretty good job of shielding things, because they secure the wires reasonably well? Don't know. Kind of all those above. We've had some pretty spectacular ones, though. Was it Swiss Air Flight 111? That the one that crashed off in Nova Scotia because of a short? It started a fire in the overhead electrical conduit. Okay. That one. That was a pretty spectacular example of a short that ruined everybody's day. This one looks like, given that all the windings are pretty well toasted, but the interior windings look like they got the hottest. These look less damaged. So this interior winding shorted, and you can see insulation is completely baked off of this. So that as a power source. And by the way, that can also be an electric motor to do the same thing. Now sometimes these guys fail mechanically. When they do, it's usually commutator brushes, something's wrong there, or bearing starts to go. If it's a bearing, you can hear it. You may not be able to tell where it is. You got a big engine running, and you can hear this. Simple solution is take a long screwdriver, long thin screwdriver, or a long stiff piece of tube, set it up against the housing of the bearing, and push it up against your ear. And not enough to damage your ear, but kind of up there. It'll transmit right through the tube and into your head. You'll hear it. When you get near the bearing, it's like, it gets real loud. Touch somewhere else further away, it gets quiet. You can very quickly identify. Now, it's going to be hard to do if you've got a propeller whizzing by your head, right? So, and that's the case, pull the thing off, put it on a test bench, and spin it up. About all you can do. If you unload it, you may not hear the bearing. The belt putting tension on it may be a part of what's causing the bearing to howl. Circuit boards. I've made a lot of money off these babies. So the more common failure when they do fail is the little San Andreas fault forms its way around here. Now what happened is you have a fairly big lead that went up through there. When this went through the wave of solder, the wave soldering technique, they weren't preheating well enough, so this lug that's sticking up wasn't hot enough. And so when it went through the wave solder, it goes through very briefly, the solder flowed into here, but this sucked so much heat out of it that this solidified, but this was still jellied, and it shrunk up just a little bit. So it created a bunch of little microfractures. And then over time, it starts bouncing around, and eventually it gets like this, where you can see it's not only completely broken free, but there's a little bit of evidence of fretting there. So that's been moving around for a while. Now, could you go in there and hit it with a solder gun? Yeah, probably. I've done it many, many times, but you know, I think it kind of depends on where you're working and what you're doing operationally. It may well be that, you know, you're not going to do that kind of a field repair. You'd pull that component out of service. That might get repaired and just flat replaced in a maintenance repair operation. I will tell you that a cold solder joint like that, That's a design problem. That's the manufacturing design problem. So if you see cold solder joints like that, might not, particularly in an airplane, it might not be a bad idea to go on the FAA website, pull out an SDR, service difficulty report, and fill it out. Say, cold broken solder joints. I'll tell you, I know of a situation of a company by the name of VDO. Some of you might have heard of them. They primarily make instrumentation, but they also made electric throttle assemblies for many, many years in the automotive industry. They kind of took it in the shorts because they had all kinds of cold solder joints, and throttle regulators were going off. Well, they stopped producing. Auto companies just stopped buying from them. Went elsewhere. Well, about 8 to 10 years later, there were 3 school bus accidents. Thomas school buses using Detroit Allison GM diesel engines that had VDO controllers on the electric throttles. And there are 3 instances of school buses accelerating into trains, and a lot of kids killed. To me, that's felony murder. The people that did that, they knowingly did the exact same thing. It was attributed back to cold solder joints, the same company, even though, and yet nothing ever happens. Product liability doesn't generate criminal negligence, unfortunately. A number of companies, Firestone's another one that has done it again and again and again, having tires disintegrate and people dying. You can kind of smell sometimes, and yeah, okay, might pop the lid, yeah, it's fried. Another broken solder joint. This one here, a torn up trace, also no solder trace pad gone there. That's probably whoever was doing the soldering got it too hot. The way these circuit boards are made is they take and make a piece of fiberglass, okay, a bunch of fiber, lay out a bunch of laminates, emboss it with, impregnate it with epoxy, turn it into a nice hard board. They then glue a layer of copper on it. The copper is bonded onto it, and then either using acid etching or now laser, they remove all the copper except for where the wire traces and pads are. Okay, remove all of that off, and so if you get this pretty hot, it'll cause the glue to debond, and that trace will come up. And it's a pretty thin trace. It's not, it tears real easily once it unbonds. So given a number of those are torn and damaged like that, my general guess is the soldering technique was too hot for there. But this is really, really, really probably the most common circuit board failure out there. Connectors, I've probably made the most money off of connectors. Pin misalignment, pin pushback, bad crimping. Now both of these, I think this is obvious that it's a bad example of crimping. But this one here is too. You can not only can you see some corrosion forming, some green forming around here, but this is kind of mashed and spread apart. There's some gapping in here. Water can very easily migrate up into there. This uses those mash type crimpers, which I don't use. They do a bad job. And this was just flat, probably putting the crimper wrong. And actually, in both cases, the yellow lug might be a little bit big for the wire that's in there. They might have wanted to go to the next size down. The one up above, that's factory, man. That's factory. You can tell it is. It's very symmetrical, very cleanly crimped. The crimp runs the full length here. The wire doesn't extend out much. The insulation runs just underneath the insulation crimp. The insulation crimp evenly comes around and dives into the insulation and grabs it all. But the only way to make that just a little bit better is put a little strain relief on it, or put it in a housing that then provides a strain relief. That's a connection that, as long as you don't submerge it, will last forever. And it's because it's crimped really well here, all of this is nicely sealed. So even if it did get a little bit moisture in there, it wouldn't work its way in and start corroding. So there's, I just threw a picture out there, but there's so many different kinds of connectors with so much potential for error. All I can tell you is, as you sort of dive into some of this stuff, you got to have the right documentation and you got to have the right tooling. If you don't have the right tools for the connector you're doing, you're going to just introduce all kinds of problems. Okay. Idiots. If you spend any time doing electrical work, you will find evidence of idiots. A big sign is black vinyl tape or red vinyl tape or any vinyl tape. Okay, vinyl made out of polyvinyl or PVC, polyvinyl chloride, typically melts at about 200 to 320 degrees, somewhere in there. Has no business being anywhere in an airplane. Obviously, this here, that's one of those pictures you just kind of want to pull off and email to every fire marshal in the county and see what they do. Stand back and watch them get all really nervous. You got to wonder, did somebody do that just for the picture, or? My guess is no. That's a yeah.
If you don't mind me saying, my mom did vending, filling vending machines a lot. Anyways, she went to some of these buildings where they were housing a lot of Somalians over in Minnesota, and they were making fires in the middle of the living room in these apartment buildings. So I imagine, the common sense factor is probably not too.
Oh yeah, that's probably a real scenario somewhere. Yeah. But the truth is, very few people understand electricity all that well. They don't have no realization how dangerous that is. And so, anyways, please, if you're doing any electrical work, be on alert for idiots. Idiots having been there before you. And if you see any evidence of that, pull out your camera, pull out your phone, take a picture, because you want to document it. I've had to do it. I hate to do it, but I've had to do it a number of times. Call up another shop, call up the manager, and say, "You need to get up here now." No, I don't care what you're doing. Get up here now. One of them was, it was a muffler shop, Midas muffler shop. Call up the manager. You need to get up here now. You don't get up here now, you're going to have fire marshal down there in about 10 minutes. You need to get up here now. Of course, he got up there, and I was sat there pointing to the bracket that one of his guys had welded to the bottom of the fuel tank. Okay, it's number 16 gauge steel, right? It's like paper thin. I have no idea how it didn't burn through and blow that entire shop off the face of the earth. Of course, he looked up at it and you could see the color just go dropping out of his. And then, of course, says, "Well, we'll do everything to fix this." Like, no, the customer's already aware. You're going to buy her a new gas tank and an entire new exhaust system, and I'm going to install it. She's not going back to you ever again. And you're going to do that, or I'm calling the fire marshal. But that's the kind of stuff that at some level you guys as mechanics have to say, I'm not going to, if I see stuff like that on an airplane, you know who I'm going to call? You guys know exactly who I'm going to call. I'll call up the FAA and say, "You need to get out of here right now." Okay? Because that's beyond, now that obviously hopefully would never be on an airplane. But I've seen stuff on an airplane. Oh God, some of the structural cutting, somebody had gone in and done some cutting where the entire doorpost on the 210, they had replaced a section and gone through and cut the entire structural element of the doorpost. And then covered it with sheet metal so you couldn't see it was there until you pulled the paneling up. And I'm like, that's a sawzall cut through that. And it was just like, no. And it destroyed the airplane. I don't know what I didn't actually entirely know, because when I called the FAA, they looked at it and said, and it went, they they went after it. So, all right, so I'm gonna stop there. And we're gonna talk about the finals. There's 2 finals. One for the lecture, one for the lab. Okay? We'll talk about it. They'll be comprehensive. Everything we've covered, plus I can go all the way back to DC electrical. You're gonna see a few of those. Might even see one of those sneaky little general questions, like a regulation question. There are 100 opportunities for success. So from the get-go, you better know what Ohm's law is, and series and parallel circuits. There aren't going to be too many calculator problems. There might be 1 or 2. And we'll see as I go through. And I'm not going to throw any of the circuit diagrams at you. Okay, so we talked about a variety of different types of systems out there. Instrumentation systems, electronic flight information systems, sensors. We talked about avionics, ELTs, transponders, nav radios, comm radios. So have some sense of what all of those components are. In a general sense of what they do. A few questions about ELTs. When do you change the battery? What do you got to do to verify it works? Some questions about some basic generic questions about antennas, as well as radio signals, right? AM, FM. Yeah, a few more questions about avionics. So you should know what the coaxial cable is, a shielded cable is. You should know some of the basic navigational systems. So you're going to have GPS, you're going to have the VOR. It's going to use the same basic system for the localizer for an instrument approach, which gives you horizontal data, the glide slope, which gives you vertical data. Okay. There are some questions about generators, commutators, brushes, armatures, rotors, stators, fields, rectifiers, voltage regulators. Yeah, probably quite a few on voltage regulators. A few on the 3-unit regulators. So what are the 3 units? What do they do? A few questions on lighting systems. Okay, landing lights, position light. What's the third one?
Taxi line.
It's kind of generally, not almost always required. Landing light, position light, and there you go. We often call them strobes, but the proper term is anti-collision light. Okay. You should know what a transistor is and what a diode is. You should know some of the basic rules around wiring. Okay. What's important when it comes to picking a wire? Amount of current, allowable voltage drop, length of the run, right? All that. Okay. Circuit protection. When it comes to circuit protection devices, what are we protecting?
Circuit.
Wire.
Circuit. Yeah. Okay. Don't care about the load, don't care about the switch, we care about the circuit. Because we don't want the little fire to come out. Yeah, okay. Several questions on wiring, wire terminations, so crimping, soldering. Oh, there's some questions about using meters. Hook up ohm meters and voltmeters. Some questions about switches. Remember that was single pole, single throw, double throw, pole, single through, double, quadruple. Yeah. Okay, what's the difference between an ammeter and a load meter? And what does that mean for you? Ammeter measures current into and out of the battery. Load meter measures current coming from the generator. It hopefully isn't going back to the generator. That would be bad. Circuit breakers, section. Remember we talked about derating switches and derating some components because of, what did we call that? What was it that caused derating to be necessary? The inrush current. Remember we turn on a light, current's really high until the filament gets really hot, the resistance goes up. Same thing with an electric motor, turn the current on, there's no counter electromotive force till it comes up to some speed. Okay. Switches. There are definitely a few questions on AC versus DC. So make sure you have a good idea of inductive reactance, capacitive reactance, power factor. Is true power greater than apparent power or less than apparent power?
Less than.
True power should be greater.
What is apparent power?
That's what it's supposed to be, yeah. Isn't it? What it's rated at?
How do you
I don't
how
know,
do you
it's
derive
not-
apparent power? Volts times amps. True power,
That's what you're getting.
that's what actually, the saw that's cutting. So true power in a DC circuit will equal apparent power, but in all other cases it'll be less than apparent power. Okay? So reactance of some kind is going to cause you to lose some efficiency. Okay. So remember when we talked about voltage regulation, I showed you one schematic that had some generators paralleling each other. We had the two carbon pile regulators, and had a circuit that balanced them. Go back and refresh yourself over that. What's happening there, and why is it important? What's really important there? Okay. Yeah, there's a couple more questions on AC generators. I'm not finding anything in the transformer. Should have something in transformer. Apparently I don't have any on transformer. Remember when we were talking about inductive reactance and capacitive reactance? In one we had lag, and the other we had lead. Remember the lead and lag? Eli the Iceman? Okay. So in one current lag voltage and the other current lead voltage. Okay. Yeah, you should also know not only what a diode is, but what a Zener diode is. And okay, so now for the lab final. These are short essay. You have to be able to actually write a little bit, maybe a whole sentence or more. So, you know, since the only thing that can go wrong is an open, a short, and a field power source, a few of the questions are going to be how are you going to determine an open, a short, and a power source? Okay, so hopefully you know how to do that. At least one or more ways of doing that. You should be able to derive some common problems that can occur in a few normal common circuits. So what could go wrong in a charging circuit? What could go wrong in a typical lighting circuit? What could go wrong? But just be able to describe a few things that can happen there. Okay, you should definitely be able to have in your mind how a DC generator is wired and how an AC generator is wired. Remember, we had delta wind, Y wound, and in the DC world we had shunt or parallel and series type arrangements. So you should have those in mind. You better be able to make use of the volt drop check. Okay. And a lot of these, by the way, come from labs. So there's going to be a question about wire lacing. What are some of the requirements around wire lacing? There's definitely going to be a question about the 3-unit regulator. Okay, so you guys hopefully learned something about how that worked. You're also going to maybe be asked some questions about the alternator. So what makes an alternator different? The field spins and the armature doesn't, and it's got a rectifier instead of a commutator, right? Okay, so, and what those things do. All right. So a couple of things. Next week, what we'll do is we'll start with the final. So you're going to need your notebooks next week. Definitely going to need to have your notebook next week. Not the following week, not tomorrow or the next day. You're going to have to need it at the beginning of the final. Because I'm going to grade all your notebooks while you guys are taking the final. So I got to have it. Having a thumb drive isn't going to work for me. It's got to be a notebook. Okay, how many of you are going to forget? Oh, there's always one or two. December 8th, that's this Friday. At 2 o'clock, the building closes. If you turn in anything after that period of time or after that moment in time, it's going to represent a 0 on your grade. Okay, it's still got to be done, but it's not going to count towards your grade. So I still have a number of people who haven't turned stuff in. Homework, the written assignment.
What about our lab prep? We're going to do lab after the final, right?
Oh yeah.
Okay.
Oh yeah, we'll get to all the lab projects. We'll be here till the cows come home. Yeah, I don't have to sleep tomorrow.
No, all
So,
right.
you know, we'll be here till the cows come home if necessary. Actually, the truth is, and looking, you guys are doing pretty good. There's a few of you that have 2 projects left to do, a couple that only have 1, and a couple that have 3. So most of you guys are doing pretty good. So if we get bang out a bunch of projects tonight, the one thing we're going to have a pinch point on is the troubleshooting. So I'm going to try and get you guys through that a little quicker. Maybe package you guys up in bigger groups or something. We'll try to get you through. But again, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of you haven't turned any of the written assignments. Okay? They were all due, right? So I've got a bunch I'm going to hand back out during class today. But so guys got to do that, or you're not probably going to pass. Particularly those of you that are already loping along in the 70s. Believe me, not getting a 0 on all your written assignments will drop you 11 grade. Okay, so if you're already at a C, I mean, I hate to be hard, but all right. So next week, what are you going to have?
Notebook.
What else?
Scantrons.
Scantron. What else?
Number 2 pencil.
Number 2 pencil. What else? Time
Coffee.
card if you owe time.
Yeah.
Okay, time card. Yeah. What else?
Coffee.
Coffee. Yeah. Okay. No lifelines. No crib notes. No.
No shoutouts. No cat cab.
Yeah. No microfilm on the back of your eyelids.
Google glasses.
Yeah, Google glasses. Is that the new thing? All right, you guys. Let's break out the lab, get some stuff going. I think I had one group, still had one troubleshooting to do on the 24 volt system.